Hello and welcome to today's lesson. We're going to find the lengths of missing sides of a special triangle called the 45, 45, 90 triangle. Okay, so we're working through to find those values. We're going to have some shortcuts, but we're also going to look at it proportionally. Okay, first we need to build what we call our reference triangle. Okay, when we look at the reference triangle here, we want the most basic 45, 45, 90 triangle that we can build. And what we do is we give the two leg lengths a measurement of 1. And then if we were to use the Pythagorean theorem to solve, 1 squared plus 1 squared equals 2. And for C, it would be the square root of that 2. So this is our reference triangle, and we're always going to compare to this. And if you notice and can use the shortcuts, that's fantastic. But I'm always going to give you that reference triangle idea to work back on and work off of. Okay, so when we're looking for these triangles and we're looking for a missing piece, notice for all of these triangles, the piece that's missing is the hypotenuse. So for each of these situations, what we would want to do is compare it to our basic reference 45, 45, 90, which is 1, 1, square root of 2, because now we can set up a proportion. A leg of 3 over the hypotenuse x, that's this triangle relationship, equals a leg of 1 over the hypotenuse of square root of 2, and that comes from the reference triangle. Okay, once we have the equal proportions set up, then all we want to do to finish this problem is cross multiply and solve. And we're done there. No difference in this last situation. We've got a leg of 5, a hypotenuse of z, and that's going to equal, coming from our reference triangle, leg, make sure that leg and leg match, make sure hypotenuse and hypotenuse match, and then from there we are going to cross multiply and solve. You know, sometimes when we cross multiply, it's done for us. We don't have to do anything else. Okay, so now, when we talk about the generalized rule, you know, this is that rule shortcut. I always like the proportions because the proportion is a long-lasting skill. It's a skill that you will use continually throughout this semester and this course. But if we want to have our conjecture. In an isosceles right triangle, if the legs have lengths x, then the hypotenuse has a length of x times the square root of 2. Okay, so that's our generic conjecture in that situation. Now, in this case, we now have the hypotenuse value. Okay, so we've had the hypotenuse value, and we are wanting to solve for a leg length. Okay, once again, we want to have our reference triangle, 1, 1, square root of 2, and we are going to go through and build these equal proportions. So leg over hypotenuse is going to equal, and then I want to go to my reference triangle, leg over hypotenuse, and then I'm going to cross multiply and solve. Now, this solving is going to take a little bit more work, because if you notice, we've got something with the x that we have to divide out to get x by itself. Okay, now, when we're here, okay, in reality, this is a valid answer, but it's not mathematically what we want for a given answer. When we're looking at mathematical process, we don't want to have a radical in the denominator, so what we need to do is what's called rationalizing the denominator, multiplying the top and bottom by that denominator value. And now we've got 10 square root of 2 over the square root of 4, or 10 square root of 2 over 2. And then if you can divide out to make your value a little bit less, okay, you always want to simplify it down as much as possible. Okay, but remember, when you cross multiply and solve, if you end up with a radical in your denominator, you're going to want to multiply that value both numerator denominator to get rid of the radical and just be left with a whole number denominator value. Okay, so now we want to find the perimeter of this square given the length of the diagonal. So what we need to do is, we know it's a square, so we know these side lengths are equal. We need to find the value of x. Okay, so what we can do is build our reference triangle 1, 1, square root of 2, set up our proportion. And once again, if you're able to notice and find the shortcuts in these problems, that's fantastic. But we always want to have something that we can fall back on that's going to work every time. So we've got hypotenuse on top, leg on bottom. So from the reference triangle, I need hypotenuse on top, leg on bottom. And then we cross multiply. Divide both sides by square root of 2. We get our side length of 7. And then to get our perimeter is 4 times the side length, or 28. Okay, so really be careful of what the questions are asking to make sure that you're answering those questions fully. Okay, so now when we're working through these, this is why the reference triangle can help so much, is we can match it up with any situation. And we just need to know, what type is it? Is it a 45, 45, 90? Or in our next lesson, we're going to see the 30, 60, 90. Okay, and then we're just matching pieces. Okay, so if we want to find missing side lengths, if you're given a length, the good part is the other length is always equal to it. Okay, so we only have to find, really one value in these problems. And then to find the missing piece, we just want to set up our proportion and solve. X over 20 equals, so hypotenuse over leg equals hypotenuse over leg. And then we can cross multiply and solve. Okay, and this is one of those shortcut values. If you can remember that the hypotenuse is always the leg times the square root of 2, that's fantastic. Okay, but otherwise we want to use our equal proportions to help us solve. Okay, and equal proportions are really going to be important when we're looking at these bottom two problems. The top two problems, okay, we're trying to find these leg lengths. Okay, we've got our reference triangle, leg over hypotenuse equals leg over hypotenuse. Okay, when we cross multiply and solve, we get these answers pretty quick here. Okay, so the top two are the way that the formula should work. It's how it works in its easiest form. But when you get to these bottom two problems, this is when you really have to be careful and set up and work off of those values. So hypotenuse over leg equals hypotenuse over leg, and then we have to cross multiply. Okay, and this is where our solving, dividing by square root of 2, is going to require a little bit of extra work. Okay, so we've got 6 over square root of 2. We want to rationalize the denominator, multiply top and bottom by square root of 2. And then we finish up, we've got 6 square root of 2 over square root of 4. 6 square root of 2 over 2, and then we can divide out that value to get rid of the denominator altogether. Does it always go away? No, but in these situations it has. Okay, now finishing up our last example here, and then we'll get you to working on these problems. Okay, we are trying to find, now we always can match up the two leg lengths, but in this case we're trying to find the hypotenuse. Okay, so we have leg over hypotenuse equals, and we go back to our reference triangle. Okay, so that's where you want to have these in your notes so you can refer right to them. Leg over hypotenuse. And then we can cross multiply and solve. 2 square root of 2 times square root of 2. X equals 2 times the square root of 4. That's pretty nasty looking 4. Apologize for that. Equals 2 times 2, or 4. So sometimes these problems work out nice and neat, nice and clean. Okay, but one thing that I would always suggest is, set up your proportion, because proportions are one of the most used skills in all of geometry. So it's an enduring skill that we can use to help make our life a little bit easier. Thank you, and have a good day.